So, welcome back, everyone. We were studying about load balancers in our previous class. I hope we have covered something related to ALBs already, right? We will cover a bit regarding network load balancers, and we'll also study a connection between an ALB and auto scaling groups. If we have already studied auto scaling group, and when we were creating those auto scaling groups, there was certain section that we have that I said that we'll be covering after load balancers. So we'll take that. Okay. And then we'll start with RDS and other topics. Okay. So this is like roadmap of at least a few days. Let me quickly share my screen and help you out with the next topic. Okay. So if you remember, there was something called as load balancers, which we were studying. Load balancer is basically like this is a domain. This domain is pointed to an IP. That IP is generally of a load balancer, which is kept in a public subnet, right? So domain points to a load balancer. Load balancer is in public subnet, which will point to other applications or instances which are there in private subnet. Okay. Now, we studied about two types of load balancers. Like which were ALBs and NLBs. We'll come to this later. So ALBs is basically for an application load. Is called as an application load balancer. It works on HTTP and HTTPS protocols, which means that this works on a network layer. I have also mentioned to read a bit about OSI models. In an OSI model, application layer is either the starting layer or the last layer of any transaction. So, which means that it is able to completely open and look inside the packet. Okay. When you can open a network packet and look inside the packet, which means that this particular load balancer will be able to make decisions based on the type of packet or some options that are mentioned in the packet, like headers, hosts, and headers, hosts, path, etc. Okay. While on the contrary, a network load balancer works on a network layer, okay, which means it only identifies TCP and UDP protocols. Okay, in this TCP and UDP protocols, all you can identify because it is somewhere in the middle in the OSI model, which means you cannot completely open the packet. Since you cannot completely open the packet, open the network packet and see what is there inside, which means that you will not be able to make decisions based on what is there inside the packet. So, what you are aware of is just the port on which the request is coming and from where the request is coming. So you can only make decisions based on the port, which is why this particular network load balancer will have lesser capabilities than an application load balancer, but will be faster than an application load balancer because it doesn't have a lot of logic. Okay, what it can do is it can just take the port and transfer it. Take the port, transfer it. Take the port, transfer it. There's not much logic that's there in this network load balancer. Okay, so it has ultra, if when you need ultra high performance, which means that you need a very high performance, that's when network load balancers are the best. Okay, when you need flexibility and you need some features wherein based on the request, based on the uh, packet, you should be able to make decisions. That kind of capability when you're looking at, that's when you'll be selecting application load balancer. Okay, so these are the two different type of load balancers. Let's see how it works. Okay. Now, before creating a load balancer, what we need? Instances, right? Because domain to a load balancer to applications or instances. Okay, so we need those two instances. So for those two instances, let me try and create a load balancer today with like an architecture today, which is very similar to architectures which we generally create in our environments. Okay, so this can vary depending upon the company that you work with, but Like this is a general trend. How do we go about? Yes, somebody was saying something.
Yeah, I have one doubt. This every time must be create VPC, ECT manually. Don't you have some template? Kind-
I have templates, but I don't want to overwhelm you with a lot of things.
oh,
Okay.
okay, okay, okay,
If you
okay,
want,
fine.
I can create everything on just one click using Terraform too. Or I can
Okay.
use some there are a couple of cloud formation templates that are available. But I want you to understand both of these things.
Mm, okay, okay.
Understand? Why?
Yeah.
Because I always say, even in my initial classes, I've mentioned, whenever you want to do an automation, okay, whether it is to automate your infrastructure, to automate your tasks, if it is Ansible, Terraform, anything, Jenkins, anything, you should first be able to replicate it manually. Always, because when you do manually, you understand, okay, these are the steps that I'll have to replicate there. Then
Mm,
only you will be able to identify what are the options, what are the code, what are the changes that I'll have to make, and accordingly you can write your
mm.
own automations. Okay.
Okay, okay, yeah.
So this is like, generally, like, it's not compulsory. Okay. There are people who just go ahead and directly write the code and all of that. But generally, this is some norm that we follow, only and only because whenever we know or we have more control over the tool, we will be able to control the automation. Example, today you didn't see that, okay, these are the steps that I'll have to perform. Okay, or you miss some step in the middle, or you understand that, okay, when I run this command, it is prompting me. Okay, so I'll have to think about fixing the prompt also when we are doing the automation. So everything, whatever you are creating, whether you're creating, example, if you want to create a MongoDB instance
Mm,
in an Atlas, okay,
mm,
MongoDB Atlas instance. So first thing, whenever you are starting any kind of automation, go ahead, create it, see all the options, see what are the different options that it provides, what are the drawbacks, what are the regions, how do I provide, what are the different like, what are the different types, as in, whether I want to create a replica set, or I want to create it in a separate format, or like, all of these options you'll be able to identify, and that is when you will start doing it via automation. You'll be able to do it even when you are doing a small part of it. Example, you already have a MongoDB, or you already have a VPC, and you want to see what is the access that I need to fix this particular issue. So first thing, what everybody does is try to do it manually, see if that change fixes the issue, then try to make that change via code, so that everything else, whatever next thing that you're going to provision, is provisioned correctly. Okay.
okay, yeah, got it.
Plus, we have not
Thank
yet
you.
started Terraform, which is why we are doing all of this manually. Okay, whatever we are doing manually right now, okay, everything can be done via Terraform too. We'll have to just understand this first. Once we have done this, then we'll go ahead and do all of these changes there as well.
Yeah,
Okay.
okay. Thank you. Yeah.
So I have two subnets here. Okay, two public subnets, two private subnets, one route table. Sorry, three route tables, one public and two private ones. Okay, and I have one internet gateway and one NAT gateway. Okay, uh, all of these two machines are actually connected. All of these two private subnets are attached to the same NAT gateway. If you see, can you see the link? VPC to two subnets to a route table, which is actually setting it to connecting to a single NAT. Okay, now I'll create a VPC. Why I'm creating a VPC is because I want to tell you how does a load balancer distributes the traffic, and how does it actually looks like, okay, in an environment. So generally what happens is, a domain to a load balancer will lie in public subnet, while your machines will lie in private, because those machines you would not want to expose. correct, to internet.
Mm.
So you only want to expose it via the load balancer. I just wanted it to be in an AWS related term to to help you identify how things are happening here. This is an application load balancer. These are two instances, but it doesn't share in terms of private and public subnet. That's what I wanted to do.
Suppose there is a web three tier, web one that can be in public, right? But need to communicate through internet.
That can be, but we always suggest to have it, even if you want to interact with internet, try interacting it with load balancer rather than having it in public subnet. So even for web, generally for web instances like your front end applications too, we want to have it in private, okay, and let the interaction happen via a load balancer only. You don't want somebody to be able to directly ping your hosts.
Okay. Oh, yeah. Okay.
Okay,
Okay. Yeah.
generally that is the trend. Why is because that is more secure way of doing the same thing.
Mm.
Okay, like if you see web server 1, web server 2, and this is this network
Because
load
I
balancer.
thought Assume Web wants to communicate to again outside. You have to if in private again you have to configure all to communicate through NAT gateway and all. So I thought, okay. Okay.
Okay, even in even in case when it has to communicate back, it will communicate using the load balancer only. So load balance, all the requests will come here. Okay,
Mm,
this is
okay.
public. Okay, this is network load balancer. We were talking about application load balancer first. So all the user will directly ping application load balancer. This application load balancer will route the request to multiple instances and others, which can be in private or in public. It's completely your choice whether you want to keep it in private or public. But
Mm,
generally, we'll keep it in private because we don't want anybody to directly reach to these systems directly from internet.
mm,
So all
okay.
the request will go to application load balancer, then to your EC2, EC2 back to application load balancer, and then your, like, this can actually send the request back because it has the public IP of this. So it can send a request back, but nobody will be able to reach this directly. So
Yeah.
users to application load balancer to EC2, EC2 will send the request back, but user will not be able to identify this IP.
Okay.
I
Okay.
will not get this IP, will only be able to see the NAT IP which is there here.
Okay. Yeah.
Okay. So it is created now. We'll be able to see the VPC. Now, since we have the VPC, I'll go ahead and create my two EC2 instances. But this time I'll create these two EC2 instances. Um, for now, I'm creating just one machine. Then I'll add one more. Okay, because I wanted you to see how it looks like. Okay. Now, networking option, again, change the VPC and change the subnet. It is in private subnet, right? 1A and 1B. So I'm just keeping it in 1A for now. I can keep 1 and 1B too. Okay. Again, yeah. I might want to give it more accesses, so I can create a new one and I can give TCP port range 80. So anywhere, for now I've given anywhere, but I can restrict it. Okay. I'll show you around how it looks like. Okay, that part. Add network configuration. I don't want all of this. Okay. So this is my EC2 instance. Okay, these are my security and security groups. Okay, so from 22 anywhere it is available, 443 and 80. But since it's a private IP, even if you give anywhere, it will no longer be available until and unless you are inside the network. So come inside the network, you need something, some bash and host or something. But for now,
Yeah.
I'll have to log into the system. Oh, okay. Let me take a bash machine because I forgot to add the user data. That's what I was thinking. So this is my bash and host. I'll create it in the same network. Bash and host is generally um, it's basically a host which is there in a public subnet and will become an entry point to your account. Why I'm saying so is because why do we need it is because you need some way to enter in your environment. Okay, because it's somewhere there in some other account, some AWS machines and all of that. So how will you enter your public instances? Via these bastion hosts. So these bastion hosts can be your, you can also create VPNs and others. Okay, you can have your own open VPN. Simple option is to have a bastion host which is publicly available. So okay, I might have forgot to add a public IP. Okay, I can add a public IP, or I can attach an EC2 Elastic IP, or I think I'll have to terminate this part. I completely forgot about adding a. So there are multiple components that we are learning together in this. Okay, just give me a minute. Let me quickly do it properly here. I'm creating it in public. It can be in 1A, 1B. It is generally going to be only one machine. Okay, for entire environment generally. Okay, but that also depends upon the company that you work with. It can be a VPN, a bastion host, a open VPN server, or or a AWS VPN. So it can be anything, whichever they decide they would like to do. So now I will go to this system. Now from this system, I'll try and connect to that system. So I am in that machine now. If you see IP 136 121 136 121. So I'm in the private IP now, private machine. So wherein I'll just start do a quick apt update. Actually, I forgot to do these things using user data. That's why I had to create a bastion host. Else you can do all of these things using user data too.
Yeah.
Okay. So generally avoid doing this. I forgot to do it. That's why I thought that okay, it's a good opportunity to do this too. That's why. So I've just started a simple Nginx server. Okay. I could have done all of this on a private machine, public machine too, but then it would be less fun than this. Okay. So I'm just looking at the configurations of Nginx right now to see what are the ports that are open right now on this. Whatever commands you're not comfortable with, it's absolutely fine. You'll slowly learn these commands. Okay, it doesn't have to, we don't have to be a pro in all of these commands to be able to solve all of the problems. Slowly and steadily, you'll learn all of this. So it's only port 80 on which we have the server. We don't have a server at port 443, if you see. Okay, because we don't have SSL, we'll have to create an SSL certificate and then sort that out. So right now we don't have it, so it's just going to be on just port 80. So I'll create a load balancer that works on port 80. Okay. Now let me start with creating a load balancer. So you got my point. What did I do? I created an EC2 instance. I created a VPC. In my VPC, I have an EC2 instance. That EC2 instance is in private subnet. Now I'm creating a load balancer. First, I'll create an application load balancer for the same thing, and then uh, I'll create a network load balancer for the same thing. Okay. I'm creating it internet facing because I wanted to show you. It can be internal too. Okay, internal means only available in the private network. Okay, which VPC you want it? Which subnet would you like to select? So I would like to select public and public here. Okay, okay. Select the two availability zone in one subnet per zone. The load balancer routes traffic to targets in these availability zones only. So it should be private and private, right? Security group is default. I can give this for now. Okay. Now select the target group. So I'll have to create a target group also. So in this, I'm creating a target group using instances. So DevOps course ALB target group. Okay. HTTP traffic. VPC is the correct VPC. Protocol is HTTP. Slash is also correct. Next. Slash is basically what you remember, right? I'll give you a walkthrough once again. So that slash was basically just the health check. Okay, so this health check should work fine. Okay, it can be any other path also apart from slash. Why I'm saying that health check should work fine is because if your health check is not working fine, okay, it will keep all the targets as unhealthy. So this health check will be used to identify whether a target is healthy or not. So it's not yet used. So I'll just go ahead and use it here. Okay. Load balancer tags. Do you want to have WAF enabled? You don't want to enable it. You want to enable it. You want to have some web ACLs or create some auto created, use some auto created ACLs, etc. And I'll create. This is basically a very good functionality that we have here, WAF. Okay, so which is why somebody would want to use it more because more than your Nginx and other reverse proxies, which also work on ALBs and you have more control, but you would want to have some protection also. So this WAF protection gives us some level of uh, what do you say? Some level of comfort. So we'll see whether our target is healthy yet. No, it's not. It's still in initializing state. So first this will become healthy. Once this will become healthy and this is in provision state, that's when we can check. Okay. Target registration is in progress, so it's taking time. Currently it's just initializing the target. We'll have to wait for this target to become healthy. To become healthy, we need 5 consecutive health check successes. Success code should be 500. Okay. Let me also check it once. Yeah, it's fine. It's 200 only. You can also see what is the response code. So response code is 200. Okay. So, and we have given response code 200. Okay. In 30 seconds, it's going to keep on pinging that machine. Plus, at the same time, we need 5 consecutive successes. Okay. Let's see. 5 consecutive successes in the interval of 30 seconds. It's healthy now. Can you see?
Yeah.
Now, in case of a load balancer, let's see whether it is provisioned successfully or not. It is provisioned, it is active. Okay, since now it is active, you can use this DNS name. So what generally happens is your load balancer will point to this DNS. Okay, this A record, and which will then point to your target. Okay, so this is the CNAME that you will be using. Like your domain will be pointing to this CNAME. Okay, and then this CNAME is pointed to other IPs which are there in different AZs and will try to resolve. You see, your Nginx is coming up fine. Okay, if you go ahead and make changes in your Nginx files, it should come here fine. Title, heading I'm changing. Welcome to DevOps course on load balancers. Okay, whatever change you'll do here will be reflected here automatically. Because your request, it's not caching anything, it's just taking the request and sending it over. Okay, so whatever will be there on that machine will be pointed it out. So what we have created now, an ALB, which is in public subnet, while your machines are in private subnet. What is happening is all the request is now going to your ALB, and then from your ALB it is going to the machine, which is actually sending you the request back. Okay,
Yeah, got it. Yeah.
cool. Now let's try to dig it again. Like if you dig it, you'll see that it has 2 IPs. So there is not a single point of failure. There are always 2 IPs. One of these IPs will be pingable, and one of these IPs, one IP is going to be in one availability zone, other IP is going to be in another availability zone. Okay, and these are all public IPs. Okay,
Yeah, correct.
now let's try and see what is the difference between an ALB and an NLB. Okay, so in an ALB, if you see, you had certain rules, target groups, other things, right? Let me just create an NLB, and then see how it looks like. How is it different? Okay. Work is going to be same, but but the way you configure it is going to be a bit different. Okay, because work, of course, should be same. Again, both these are created in public one, public two, right? Now I will create a target group again here, but this time I'll have to create a target group for TCP, right? Correct? TCP port 80. Earlier it was, wait, you have created a target group. It should come here. But why it is not coming here? Because target group for an ALB and NLB is different. For an ALB target, the target should be on HTTP and HTTPS protocol. Okay? When you are creating an NLB target, it should be on TCP and UDP protocols. Okay, right?
Yeah.
Correct? That's what we discussed initially. Health checks is going to be same. You can have some advanced health check as in override, like I want this health check to run at port 8080 or some other port and other things. Now I'm not doing it. I'm just using it on traffic port, that is port 80, as in request is coming on port 80 and health check is also happening on port 80. Okay. Yours, our success code is 200. Although you can have a slab, you can have a range also. So next, port 80, including, it looks similar, but look at this TCP protocol very carefully. So this is HTTP protocol, which is why it is called as an ALB target. Okay, and it will only be available for ALB type of load balancers. While target here is TCP, which is why now it will be available here. And an ALB one is not visible also here, right? Why? Because of the protocol it can understand. Okay, you can add more listeners to it. This is one listener. You can add 443 listener or other ports also here. Okay, you want to need you need some accelerators or other things, you can add. I don't need it. So for the time being, I'm just creating a network load balancer, a simple one. So when you create a network load balancer, things are going to be very same here. It's going to perform all the health checks. Once it performs all the health checks, initializes it successfully, only then request will fall into place correctly. Okay. This is going to be your DNS. This is an NLB DNS. If you see the listeners, it is TCP 80, and let's see the listener on an ALB. Okay, in an ALB, listener and rule is on HTTP. Okay, there are target groups, there are rules, ARNs, etc. While in this, it's no longer like that. Okay, you cannot have any rules here. Why you cannot have any rules? Because you cannot see that packet, so you don't have capability to perform any decision related activities based on the packet. While in ALB you can do that, so we can add more and more rules here. Okay, example, this is the default rule. I can add one more rule saying that this is the name of the rule. Okay, these are conditions. I'll add a condition saying that if path is /test, then give a fixed response of 200 in a JSON format and say Sage. This is from a fixed response. Now, before I make this change, okay, let me check the load balancer once again. This is working fine. Okay, it's on HTTPS. HTTPS is not there, right? Okay, because we have only configured port 80. So at /test, it is failing. If I don't give /test, it is not failing. Okay. Now I'm adding a rule that if request is coming at /test, then give a fixed response. Next, priority of this rule, I'm sending it as 100. So all of these rules are sequentially organized. So if it matches with whatever first it matches with, it will be executed. Okay, so I have a, so earlier you remember slash test was not working. Now it's giving a fixed response.
Okay.
Okay, why? Because I am giving a fixed response with a JSON type. That's why this started coming. Okay, if I remove it, it's like this. If I add slash test, it's like this. These kind of conditions, rules, application of rules, um, redirection based on the paths, based on certain conditions is something that's not possible in a network load balancer. So let's see if this network load balancer is initialized. Yes. NLB target is initialized. Let's see if network load balancer is active. Yes, it is active. So all of these things, what we have done here, cannot be done in a network load balancer. Yeah, you see? Now, if I want to do something like slash test in a network load balancer, I cannot do it. Okay, it will anyways route the request to your application, irrespective of whatever you do.
Okay. Yeah.
Okay, so this is simple. Up till now, it is very simple. Okay, now let's do it with auto scaling. So you want to do this with auto scaling now or later?
We can go.
Sorry.
No, I said we can do no.
Yeah. So I'm doing an auto scaling group again. I have a template. I'm using this template. Next, override the template. I am creating it in this VPC only. Zones that I'm creating it is in private and private. Okay, that's what I'm selecting right now. This security group, and I think I might have to create a uh, new launch template, because the launch template has some. Or can I use this one? Sorry. I don't think I want to take that risk of having it in different subnet once again. So I'll create a new security group. I have given VPC in which I want to create it. I'm giving your port range 80, anywhere 443. I don't have to give 443, but I'm giving it now for the time being. Advanced details. I want to probably give it some user metadata, yeah, which is already there. It is base 64 encoded, which is why it will execute. Uh, okay. So I'm creating a launch template for the time being. So I've created a launch template. After creating a launch template, I'm updating it to this one. Next, availability zones. I'm giving these to, I have to update the VPC. I'm giving private and private. Why? Because I want my instances to be in private subnet. Next, attach to an existing load balancer. Okay, so I can attach it to ALBs and NLBs or both or one. Okay, so I'm attaching it to an ALB. Next, scaling capacity one, max capacity, desired capacity, maintenance policy. I don't want to do it. Next, next. All the other options we have mostly discussed. If in case you have some issues with any options, you can let me know. Okay, now what I'll do is I'll delete the instance that I already had, this one, because I want auto scaling to create an instance for me and let it attach to the load balancer, application load balancer. Or I can remove it from the application load balancer target group by default if I want to. Okay, so this is the target group. This is that machine. I'll deregister it. So it is removed now. But there is one more that is getting initialized. This is coming in from auto scaling. Remember, auto scaling, we have just enabled auto scaling. In auto scaling, we are creating one instance. That instance is going to be this instance management. That instance is going to be this. It's healthy. It's going to be attached to the load balancer, as I already mentioned. In their option, I've enabled attach it to an existing load balancer, which is why it is trying to attach it to this load balancer. Since this load balancer is attached to this target group, so it's trying to attach it to this target group right now. So I've removed the previous one and there is only a new one that is there. But it is still not able to take care of all the health checks. Now let's see, let's go inside this machine and see, identify what is happening. I'm not sure why it has a public IP. I think I accidentally added this. I think in security group I have not added 22 at all. So that is one thing that is missed. So I'll add SSH port everywhere for the time being. Okay. Still, it is not able to connect. So, which means I think I'm right. It's creating it in private only, but I don't know why it has an IP because I might have selected that option of having it in uh, having a public IP. That's why it's in private subnet, so it won't be able to reach. So now what I'll do is I'll try to connect to this machine via this private. So from Bastion, I'm trying to connect to that machine. Okay, so this is that machine. Let me see if Nginx is running. Okay. So once it is already automatically like provisioned, it will be able to become healthy, but it might take some time, okay, for it to become healthy again. So this is how via auto scaling a machine is directly attached to a load balancer. Right now it is unhealthy, but give it a few more minutes, it will become healthy in some time. Okay. Or you can rerun or force run the health checks. To force run the health checks, we might have to like deregister and register it, which I don't want to do. Okay, so let's wait for a few more minutes. It will keep on running like the health check till the time it finds this healthy. Okay. Now, do you understand the point? Do you understand what is the flow? A bit.
Yeah.
It was simple, but yet it is a bit complex than the usual things that we were working. Because in usual things, there was only one or two components. Here, there are multiple. We have a VPC, we have subnets. In the subnets, we have EC2 instances. Then we have two load balancers. Which load balancer is routing the request where is something that you should be able to visualize now. Okay. If in case you have any challenge, okay, you can let me know. I can get it sorted for you. Okay.
Yeah, sure.
It will take some time to become healthy because we need five consecutive success health checks for it to become healthy and two consecutive to make it unhealthy. So we'll have to wait for five consecutive health checks, successful health checks for it to become healthy right now, which we don't have to do automatically. Your load balancer will take care of it, but we have to wait. Okay. Any other questions so far, guys?